3 is called DeMoivre's theorem. And if I gave you a complex number and then raised it to a power, let's do 1 minus I squared. This would be real easy to multiply out and simplify it because it's just squared. So you could just distribute, FOIL, whatever you consider there, and we would get 1 minus 2I, and then we'd get plus I squared. You know that I squared by definition is -1, so the 1's are going to add out, and this is going to simplify to -2I. All right, however, if I came along and said, all right, now take this complex number and raise it to the 10th. Well, you don't have enough time to multiply 1 minus I out 10 times. So what we have here is a theorem that helps us evaluate these complex numbers if they're raised to a power. All right, so we already know how to convert a complex number to polar form. We need r and theta. All right, so we already know how to do that. Now what we're doing is taking that r and we're going to raise it to that power. And then we're going to take that theta and multiply it by that power. All right, so if we've got this complex number raised to a power, that power is going to be n, right? We're going to do the same thing we did to write it in polar form, except we're going to raise r to that power and then multiply theta by that power. All right, so let's look at the example that I was talking about up top. So 1 minus I to the 10th. So let's write out everything we need. So this is my complex number. The real part is 1. The imaginary part is -1. My power, my n value here, is raised to the 10th power. So my power is n. What else do we need to know? We need to know what quadrant this is in because we've got to find theta. So 1 minus I would be to the right and down. So I know this is quadrant 4. All right, so let's find r. We know that r is going to be a squared plus b squared, and that's going to be the square root of 2. And if you need more detail and find an r and theta, you need to go back to the previous video. All right, our theta is, tangent of theta is b over a, so that's going to be -1 over 1. You know our reference angle for this is 45 degrees. I'm coming out of quadrant 4, so that's going to be 360 minus 45, or theta here is going to be 315 degrees. All right, so now that I have r and theta, I can write it in polar form, and I'm also going to go ahead and raise r to that power. So I've got r, my r was square root of 2 raised to the 10th, and then I've got cosine times, I'm going to multiply that theta by that same power, so 10 times 315 degrees plus I times sine, and multiply theta by n again. All right, now this isn't like when we went from complex form to polar form, we left it. This is actually evaluating. We're simplifying this, so we're going all the way with this. All right, so we've got the square root of 2 raised to the 10th power. Remember that when I square a square root, the radical goes away. So I know the square root of 2 times the square root of 2 is 2. Well, how many square roots do I have? I have 10 of them, but that's 5 pair. So really this is 2 to the 5th. All right, that's getting rid of that radical. And then inside I've got the cosine of 3150 and multiplying it by 10 plus I times the sine of 3150. Let's put that in parentheses. All right, so let's keep going. 2 to the 5th is 32. All right, so this is going to be something that's going to be really easy to plug into your calculator. So when I plug this in my calculator, I get that the cosine of 3150 is 0 plus I times the sine of 3150 is -1 So I'm going to distribute that 32. So 32 times 0 is just going to be 0, and then I've got the 32 times I times negative 1, which is going to be negative 32I. So that's my answer. 1 minus I raised to the 10th power. By using DeMoivre's theorem, I found that that is negative 32I. All right, let's do another one. All right, let's write out all the information I need. I know A, square root of 2 over 2. B, same thing in this case. What quadrant am I in? I'm in quadrant 1, positive, positive. What else do I need to know? My n value here, my power is 12. All right, so I'm going to find R. R is the square root of a squared plus b squared. Right, and that's going to be 1/2 plus 1/2, which 1/2 plus 1/2 is 1, so the square root of 1 is 1, so my R value is 1. My theta is going to be B, tangent of theta is B over A. Anything divided by itself is 1. We know we're coming out of quadrant 1, so theta here is 45 degrees. And then when I evaluate this using DeMoivre's theorem, so I'm going to have R raised to that power times the cosine of that power times theta plus I times the sine of that power times theta. All right, and so I've got 1 raised to the 12th, 1 raised to any power, 1 raised to the power is 1, and then I've got the cosine of 540 plus I times the sine of 540. All right, the cosine of 540 is negative 1. And the sine of 540 is 0. And so I've got negative 1, 1 times negative 1, which is negative 1. And then I've got 1 times I times 0. Anything times 0 is 0. So my answer is negative 1. Now, if you'll notice that these answers, sine of 540, those were super easy because I could plug them into my calculator, and they ended up being quadrantals, so they came out real nice. If you end up with something, and I'm just going to make this up, so let's pretend that we end up with something like, let's just do 6 on the outside times the cosine of 135 degrees plus I times the sine of 135 degrees. All right, you have to evaluate this, and it doesn't want an approximation, so you're not going to be able to plug cosine of 135 degrees into your calculator. All right, you know how to evaluate this and get an exact value. Remember that the cosine of 135 degrees, this is in quadrant 2. My reference angle is 45 degrees, and so this is going to be negative square root 2. Right, so this would be 6 times negative square root 2 over 2 plus I. The sine of 135 degrees would be positive square root 2 over 2. All right, so notice I don't have any approximations. I didn't round it to any decimal places, and I'm just going to keep evaluating this, so you know how to evaluate these exact values. So that's what you're going to have to do here. When I distribute my 6 to both of these terms, that 6 is going to cancel and leave me with 3 out there. So I'm going to get negative 3 times the square root of 2 plus I times 3 square root of 2. And that would be an exact answer. So be careful with those if they don't end up being quadrantals.